Okay, so this section is about logarithmic integration. Like, basically, if you understand what's written here, which is like the integral of 1 over x is ln of x plus c, this is kind of something we memorized, right? If you think about it, we know if y is equal to ln of x, y prime is equal to 1 over x. So it makes sense that if we were to reverse this, integrate this, right? Well, we integrate y prime, we get y, in a sense. When we integrate 1 over x, we get ln of x. But we need to use the absolute value because, in this case, in the red circle, x can be positive or negative. It's cool. It doesn't matter. But in this situation, x cannot be negative. You can't ln negative numbers. So the idea is that how are we going to use this for more complicated things, not just 1 over x now. Let's make it a little harder. So basically what I'm trying to say is that if you see a derivative over an original function, so this is the function, and this is the derivative up here. If you see that, you know that you can use this log rule. If you think about back in the day, we had y equals ln of 3x squared. Well, how did we get y prime? Think about what y prime is for a second. Well, what you do is you take the original, you put it on the bottom, so it's 1 over that, but you chain rule it, so you actually multiply by 6x. Or you just do the original over the derivative over the original. Derivative on top, original on bottom. So that's just like getting at what we're doing tonight. So let's say we have this example. It's not in your notes. But if we did, which would be the function and which would be the derivative? Which of these would you pick to be the function? Well, I would pick the function to be x squared plus 1, making my du 2x dx, which is really this. And now, what you can do is you can write the integral of, right? It's something over u, and really, if you think about it, it's 1 over u times du, or it's du over u, whatever way you want to look at it. But when you integrate that, just like when you integrate 1 over x, you get ln of the absolute value of u plus c, which of course needs to be put into x's. So that's x squared plus 1 plus c. Now, if you don't believe me, take what's in the red circle and derive it. Just take the derivative of that. And it will come out to your integrand. It will come out to what's inside your integral right here, this part. Okay. So let's talk some examples. So similar, actually, in a sense, kind of an easier example, 1 over 2x dx. And they're telling you that u is 2x and du is 2dx. So that's helpful. But if you think about it, here's that 2, it's taken care of. Do we want a 2 in this situation? Do we want this 2 here? No. So we divide it on both sides. So now let's rewrite our integral. You have the integral of, so this is equal to the integral of, okay, 1 over, I'm going to call that u, because that's 2x is u. And then dx is actually equal to du over 2. So du over 2 is actually equal to dx. So I'm going to put the du here, and I'm going to put the over 2 here. Pull it out. And at that point, this is the form, or you can rewrite it as this if you want. Derivative over original. And that's going to give you ln of the absolute value of u. Of course, you can't have u in that term, so you need to have 1/2 ln of the absolute value of. And what was u? It was 2x. Plus c, don't forget. What we've done is, on a lot of these problems now, we're going to take the numbers off of your integrals so you can get the general idea. So you don't have to worry about plugging in numbers and subtracting and basic math. You can just worry about the calculus part of it, the techniques, and that's where we're really going with this. So it's the same thing as any other u substitution, but the answer has an ln in it. Okay? Because when you have u to the -1 in an integral, you can't say it's u to the 0 divided by 0. You can't add 1 divided by that. It doesn't work. So it's ln of u. So a little bit of talk here. I think this is in your notes. These are all just like problems that can be all integrated. I think all of these can integrate by the log rule. Okay? Well, these are actually all the examples. I think these are going to be the examples from your notes if you look at it. So if you look at all of these forms, you can look at them and take a kind of a peek at what we're trying to be able to accomplish. These are literally the book examples, the examples that you'll have in your notes. We just did that example. We're going to do this example in a second. And all of these types of problems can be done with ln of some u, whatever u is. We don't know what u is going to be. But once we can figure that out, we can use u substitution again, or substitution by change of variables, some people call that, to get us where we need to be. Okay? There are some fractions, rational functions that you cannot integrate with the log rule. Maybe you could think of one that wouldn't work. I don't know. But what you notice is that if this is third power, this is second power. This is second power, this is first power, right? Most of the time. Not every single time, but that's a general rule of thumb. As you get down to the bottom, they get a little harder. All right, let's do another example. So we call it change of variables instead of u substitution sometimes. You can call it either. So let's look at this. Let's write it as a nicer form. 1/4x minus 1 dx. And they're telling you what u is. They were very nice, and they told you what u is and what du is. Do we want, there's a 4 here, and that's this 4, right? So do we want this 4 here? No, so we divide by 4. So just be aware that du over 4 equals dx. Okay, rewriting our integral. So we cannot use any x's. We have 1 over, in this case this is u, because 4x minus 1 is u. And we know that dx is equal to du over 4. So let's just kind of show that real quick. Du over 4. I don't like to have the over 4 there, so I take it out front. A couple ways you can look at it. You can say it's 1/4 1 over u du, or you can think of it as 1/4 du over u. Either way, it's the same thing. And that means that the answer, when you integrate, we have not integrated yet. When you integrate that, the general rule is that that's ln of the absolute value of u plus c. Now this 1/4, by the way, can go like this to the c, or it cannot. It doesn't really matter, actually. So for simplicity's sake, we're usually just going to do it like this. We're going to let that constant deal with the integral, but with plus c is not going to have the constant wrapped into it, or it's just going to be its own thing. And there's a longer explanation for why that is, but we're not going to get into it on this lesson. It's not the point of the lesson, and we have a limited amount of time. So this is your answer, but of course we can't have an answer with a u in it, so it has to be 1 over 4, because our question was asked with x. So it's got to be 4x minus 1. Don't believe it? Take what's in the black circle and derive it. Just treat those absolute values as parentheses when you're doing it, and it should work out just fine. Okay? So that's kind of where we're at for now. We'll keep this video kind of short. I'll have you try a couple problems. There will be another video accompanied. You'll have to take more notes, but I want you to try these two problems right here, 351, number 5 from the book. Think about what your u would be. Think about what your du is decided then once you pick your u. Look at this one. Think about what your u would be. This one could be a little trickier, so take a few minutes on this one. 5 I think will go okay. 21 might be a little harder. So take a minute, pause the video, and actually we'll end the video here, and there'll be another one. So please continue on to the next video once you solve these two.